Penrose Theory and Art.
Math isn't typically what comes to mind when thinking of a creative individual, but math has a lot to do with creativity, as the two tend to feed off each other, especially in art. Art is used in math in graphs and lines, and math shows up in art in strategic equations used to create specific visuals, such as illusions and perspectives. The Penrose singularity theory made a grand impact in the science community by proving that Albert Einstein's relativity theory leads to the formation of black holes through his idea of trapped surface. This addition to the relativity theory won Roger Penrose a Nobel Prize in Physics due to its grand impact on the science world.
Robert Penrose's discovery was incredibly meaningful to the scientific community. He even went on to win a Nobel Peace Prize. Here is the diagram Penrose used in assisting his discovery.
But that's not the only impact his work had. The art world also gained valuable new diagrams to use in order to create forced perspectives and illusions. The incorporation of perspectives in art really helps to create dimensions that incorporate depth and value into art. Forced perspectives are very popular in the art world, with one-point perspectives, two-point perspectives, and atmospheric perspectives appearing in the works of artists such as Van Gogh and Leonardo da Vinci. These forced perspectives are used through the help of geometry involving straight lines to make a grid or more curved lines to make a shape that stands out. Penrose's theory was similarly adapted into art, as the theory demonstrated diagrams of curved lines enveloping into each other continuously to demonstrate the math of a black hole, leaving physicists astounded by the new concept and artists in awe at the beauty of the diagram. The way in which the lines curved into each other, seemingly infinitely, to prove that anything, regardless of which direction it was going, would be sucked into a black hole, was a fascinating sight. Artistic techniques quickly modeled these theories to create beautiful perspectives and illusion artwork, making good use of the infinite aspect of the theory: the Penrose diagram, Penrose triangle, and Penrose stair.
Here is the Penrose diagram describing the black hole. Here is the Penrose triangle, which as can be seen, is attached and seems to be never-ending in an endless loop. Here is Penrose staircase, which also is attached and seems to be in an endless loop, constantly going up or constantly going down, depending on which way you look at it.
All three of these concepts in their own right form an endless loop that seems to be infinitely continuous. These visuals representations of the theory grew to develop into illusion arts, with artists such as M.C. Escher creating beautiful pieces that incorporate these diagrams. The Penrose stairs is a concept Escher used in his piece Ascending and Descending, which showed an endless staircase that constantly went upwards as if never ending.
And here you can see that piece of art with the men on the staircase endlessly going up, endlessly going down.
Another of Escher's art pieces, appropriately titled Relativity, used the same concept of the Penrose triangle to create the illusion of seemingly impossible stairs. There are three main staircases that all point in different directions that completely defy gravity, yet seem completely connected to one another, forming an endless loop that really makes it seem infinite.
Here you can see the piece.
The piece had such an impact that it even inspired Roger Penrose to write a mathematical research paper on seemingly impossible objects. The sparks of creativity flow both ways, with the physicist influencing the artist and the artist influencing the physicist. M.C. Escher isn't a mathematician himself and could probably not explain the concept mathematically like Roger Penrose could, but Roger Penrose would not be able to demonstrate the theory visually as intricately as M.C. Escher.